really shouldn't expect that it's going to be able to solve problems that were hard to begin with. Those problems are going to remain hard. Problems that involve human communication, human interaction, integration of the work that you do, that I do, that many other people might contribute to. Putting all of that together was hard before. It's still going to remain hard. I don't have any problem with using AI-generated art. The interesting ethical dimension to it, of course, is at some point, will AI-generated art start replacing human-generated art?
Do you see there is going to be any impact on employment and jobs for these software engineers? Joining me today is Dr. Nenad Medvidović, Department Chair and Professor of Computer Science at University of Southern California, USC. Neno, welcome to the program.
Thank you. Thanks for having me. Good morning.
Good morning. So you are a Professor of Computer Science and Department Chair at USC. You have taught software engineering for a long time now. And I'm assuming in the late 2021, you were probably sitting at your desk when you received the news of ChatGPT was released. What was your first impressions?
That's an interesting question. Transporting ourselves back to that moment it's a little bit tricky just because ChatGPT has been so ubiquitous and it's changed a lot of things. And there was a lot of buzz, especially early on. So right after it was introduced in November of 2022, in a way, it was a game changer, or at least it was put forth as a game changer. And my general attitude as an academic and a researcher is one of wait and see, but you could tell that this was different and it was going to force us to rethink how we do various things. And it has actually, it's delivered on that promise, at least. The buzz or the hype has subsided a little bit in some ways. In other ways, it's actually grown even further. But I think it's fair to say that ChatGPT has kind of put November of 2022 as sort of a watershed date. So pre-November 2022 and post-November 2022, those, at least as we sit here in, mid-June of 2024, I think that's a delineating line. I think it's fair to say that. And it doesn't happen very often that one can kind of point to a date where they go, hey, I think we're facing history then. And I think this was one of those dates. Now, what its actual impact is going to be long-term, we can talk about that. And many have speculated. And as much as I don't like to very often in the position that I'm in, I'm actually forced to speculate on those kinds of things as well. So we can, as I said, we can talk about that. But in the short to midterm, it definitely was, as I already mentioned, a game changer.
Why do you think it received this much hype? What's so big deal about these large language models?
The thing that was different from the things that existed before, or things that came about before, is that all of a sudden people felt like there were these endless possibilities, the ways in which you could use it, the ways in which it kind of manifested itself, the range of applications that were possible. All of these things just kind of exploded and were significantly broader and deeper in many ways than what was possible before. So all of a sudden, I can talk to you about how this manifested from the perspective of an academic. We had to think about what this meant for homework assignments, for programming assignments, for class projects, for writing essays, for expressing one's ideas. As a researcher, I had to worry about what this meant for my students who typically, and we can talk about that as well, they're incredible engineers, and when I say my students, I mean my PhD students with whom I work on a daily basis, who historically, in my experience, and I think this goes beyond just me, they struggle with expressing ideas and being able to state them in ways that are understandable to other people around them. All of a sudden, this tool came about, and it helped them formulate and phrase things in ways that were significantly better than what, for example, an entry-level PhD student typically can do. So now you see these overt improvements that were instantaneous, right? On the other hand, what you're also seeing is this potential downside of this is the lack of desire to improve, right? Because you can have this tool, it becomes almost like a crutch. So why bother writing better? Why bother trying to express your ideas in a more concise way, in a way that kind of pinpoints what the essence of the issue is, when you can have this tool that can do it for you? So you can be discursive, you can be sort of like the way this answer is going on right now. You can, kind of dance around the issue, and you can have this magical, almost magical utility that can grab that and get to the essence of it and express it in ways that were pretty incredible. And that was kind of the first impression behind ChatGPT. And then the problems came along with it, right? And other large language models as well. Just yesterday, I was reading about Google's Gemini and the issues that it's experienced and so on. And then it went beyond just how we express ourselves in everyday interactions, right? It went to how these tools and whether these tools can be used for things like programming and building software systems and so on. So the promise was sky high. The actual quality delivered may not be there just yet, but those are maybe things that can be ironed out over time. The actual issues that underlie this are beginning to emerge, and those are actually much more serious issues. And we can talk about them, and I would actually like to talk about them today, because I firmly believe that there is a real danger of not necessarily overselling these tools, because OpenAI or Google or Microsoft, they're supposed to oversell their tools, right? That's what they want. They'll tell you what they want you to believe. So they want the public to actually buy into this stuff. But as kind of a discerning member of the public, you need to know what you're getting yourself into. From the perspective of a software engineer, I actually have very strong opinions about what this can do for us, but then also where the dangers lurk and what it cannot do for us.
So from my experience, when ChatGPT was released, and the reason why I started this podcast and I got super fascinated by this whole field, my fascination did not start in 2022, but I was reading Ray Kurzweil's work way before, and I always thought this is science fiction, this is way in the future. But then when ChatGPT was released, I felt I'm conversing with the hive mind of humanity, this collective intelligence. Everything that we put on the internet is now accessible to me in a natural language, as if I'm speaking to a person. And for me, that was the aha moment for me. This was very, very inspirational. And the question for you, since you know how these languages operate from the deep end of technology and software engineering, are we speaking to a hive mind when we chat with a ChatGPT or Gemini or Claude?
So that is, I think, a reasonable characterization, that you're speaking to a hive mind. It does sweep under the rug a lot of different details, right? And in some ways, you'll hear people that it's also just a gigantic statistical model that grabs a lot of stuff that's out there and then regurgitates it for you. But then, on the one hand, sure, that's a fair characterization. But on the other hand, it's kind of underselling it, right? So the truth is somewhere in the middle. Because when you speak to, let's say, a 12th grader, right? When somebody who's a high school senior, when you talk to them, very often what you're going to hear from them is a lot of things that sound like human intelligence, but really that is 12, 13 years educational indoctrination, right? They've been forced to retain a lot of information. They learn a lot about history. They learn a lot about geography. Two of my favorite subjects, by the way, outside of computer science. So when we talk about these things, and you may feel like, hey, this person knows, a lot about the history of this particular region. In a way, Yes, I do. But what I'm doing is really I'm kind of assembling and regurgitating information that I've learned from elsewhere, right? It's not, I'm not using kind of my creative abilities. I'm not necessarily generating any new knowledge. I am somehow synthesizing and then extrapolating from a lot of existing information that I may have read about in my spare time, right? And that's exactly what ChatGPT does. So, or any one of these large language models. The other thing that's also very interesting is when you and I talk, if you don't know about a particular subject and I profess that I do, I can actually introduce latent errors or overt errors into what I'm saying, and you wouldn't know one way or the other. And that's kind of the same thing that you get from these models, right? And then occasionally we'll catch them in quote unquote a lie, right? And then this becomes a big deal where people go, well, the accuracy is not 100%. Well, it's never going to be 100% probably during our lifetimes. But then the accuracy of a human expert is rarely going to be 100%. People just make mistakes. They, misremember things. They don't know everything. There's always room for improvement. So I feel like from that standpoint, it's almost like talking to a sentient agent, right? And this sort of what you call the hive knowledge, or what you refer to as the hive knowledge. But it's important to keep in mind that these tools, these models, know only as much as they're able to gather from whatever the written records that exist out there are. And those records themselves are flawed. And of course, the models themselves are not fully accurate. So you have this incredible kind of computational wherewithal thrown at this problem. And in the end, it's going to get something that's in some ways pretty well in the ability to give you intelligible answers to some very tough questions. And maybe it's not unfair to expect that some of those things are going to have errors in them as well. So this, I feel, is sort of the positive side of this entire revolution that was started with the release of ChatGPT, whatever the version was, as of November of 2022, and then many of the large language models that people experimented with before. I feel like at some point, the ability to computationally deliver on this and to process these ginormous models and amounts of data finally kind of delivered via this capability that we're availing ourselves of today. So any complaints about, hey, it makes mistakes, yeah, I don't know that necessarily those complaints are fair. Of course, it's going to make mistakes because we make mistakes, and the resources from which it draws themselves are flawed. So from that standpoint, it's fine. I think the problem is the opposite end of the spectrum, where people are actually overselling it and expecting possibly more from it than it's actually able to deliver. And that's where, for example, as a software engineer, I could see a huge potential danger and a lot of room for improvement. And I'm actually not sure. I feel like there's going to be a little bit of a correction, not necessarily a backlash, but a little bit of a correction because of some of the real issues that people in my field are beginning to notice when trying to use automated tools. I also tell you that before I ever saw ChatGPT in action, I was in a meeting where a person from GitHub showed us a demo of GitHub's Copilot, which was still in its beta version. It still hadn't been released. And it was pretty impressive. And it's, again, kind of a coder's, maybe you can think of it as a coder's or an engineer's equivalent of ChatGPT. Again, the early promise was really fantastic. And then some of these deeper issues came along, and we can talk about them. So I think it's important to kind of have this balance in mind. Not to expect perfection on the one hand, but also not to expect perfection on the other hand, meaning that we shouldn't really complain about one of these tools not being exactly what we need it to be. Well, maybe it shouldn't be, right? Because none of us are perfect. On the other hand, we really shouldn't expect that it's going to be able to solve problems that were hard to begin with. Those problems are going to remain hard. Problems that involve human communication, human interaction, integration of the work that you do, that I do, that many other people might contribute to. Putting all of that together was hard before. It's still going to remain hard. And then there's some really subtle software engineering / coding issues that have emerged over time that I'm not surprised by at all. In fact, I'm actually kind of surprised that people are puzzled that those things are out there. They should have known. We've known all along that there are some of these things that are very difficult. Those problems were never solved. Just throwing another tool at them. We used to have a manual screwdriver. Now we have a power screwdriver. But it's still just a screwdriver. It doesn't. It requires human ingenuity to actually solve the problem for which this tool is useful, essentially.
Yeah. You lead the Department of Computer Science of one of the most prestigious universities in the world. And you'll probably be the best person to ask you about how these networks work. And the strange things to me, or maybe not strange, but the interesting thing to me is the language we use to describe this technology. For example, we use neurons as if similar to our brain neurons. So we use neural nets, right? We use many of the terminologies we use to describe our brain. We kind of use them to describe these networks. Now, the question is, do you think with these models, are we learning more about the brain, or are we departing far away from the brain?
That is a very interesting question, and one where I have to, for the record, state that my expertise kind of stops at the point at which kind of the computing neural networks end and the biological neural networks begin. It's definitely the case that neural networks, as we use them in computing, were inspired by how human brains work. There's no question there. Now, are the two models isomorphic? I would seriously doubt it. Although, again, I don't really have expertise in the biological side of the equation, if you will. I do feel like there is a lot of kind of mathematical, maybe simplification or restating of the problem, because on some level, the way we approach these neural nets require a lot of, let's say, statistics, for example, and a lot of heavy-duty data processing. And then there is some other stuff that may fall under maybe more traditional computing and or software engineering domains. So from that and also the other thing that's very important is we're trying to simulate in an inherently digital world, we're trying to simulate analog phenomena, right? And so those are the differences that we know exist for sure between what's happening in computing and what's happening in the real or biological world. There's this quote that I have used in some of the classes that I've taught. All models are wrong, some are useful, right? So by definition, the model is not going to be exactly the same thing that's happening in the real world, but it is a useful approximation because it can actually help us mimic some of the same phenomena. The other thing that we're struggling with, of course, is the scale of the problem. So now we've actually been able to build these incredibly large models with billions of parameters and neural networks with billions of nodes, and that is beginning to get to the point where it may approach the scale of what, let's say, the human brain may consist of in terms of its internal structure. For a while, and I think that's why it took a couple of decades from the point at which neural networks were proposed to the point where they actually started delivering on this promise, and everybody jumped on that bandwagon after having ignored them for whatever it was, almost 30 years, right? Because computationally, we were not able to handle the scale and the complexity, right? And a neural network becomes more useful as it grows larger and is capable of processing more information. So now we, for the last, I don't know, maybe 15 years, we have been entering this era where we're actually able to do very useful things in computational neural networks that have been brought about because the scale of the kinds of problems we were able to solve, and the kinds of models we're able to process and generate, that scale finally has kind of crossed this threshold of actual practical usefulness. So the models are probably, the reason I'm saying probably is again because I want to be very careful with my limited understanding of how the human brain is organized and how it works. The models are probably fundamentally different, but since as a software engineer I talk about abstraction being critical all the time, when you abstract away the low level details, there is a fair bit of similarity, and I think that's what makes it really attractive to a lot of people because what we're trying to do is basically build a, you can think of a computer-based neural network as almost like constructing.
And what's scary is that the human brain is not scalable. Like you cannot enlarge the number of neurons in a limited human brain or in an average human brain, where in an artificial neural network, you could keep expanding, build more data centers, make more parameters until, and that's when, Rakers will talk about the singularity, and that's why my podcast is called Singularity. Do you think this is hypothetical, or we're gonna really have AGI and artificial superintelligence and entities that exceed our intelligence as people?
I'm a little bit dubious about that, but then maybe I'm just thinking in terms of sort of what's going to be achievable within our lifetimes. Maybe at some point this will get to the point where it's at least capable to mimic such a super intelligence. I just want to be very careful with what we have so far. I don't think this is intelligence in the traditional sense of the word. I think it's capable of mimicking that intelligence by accumulating huge amounts of information and being able to combine and recombine it in ways that may seem interesting and novel to us, right? But its ability to actually generate something truly novel, I don't think we're quite there yet. But people who are much smarter than I am, who know a lot more about this than I, have actually expressed serious concerns about this. And that there are those two camps: people who basically say, "Hey, we really need to watch out for this because AI is going to take over," and people who say, "Hey, this is vastly overblown. We're not, anywhere near there yet." I think those two camps are going to be interesting to watch and see which one of them is going to prevail. The one thing, as a maybe a non-expert but a highly informed observer, since my specific area of research is not neural networks, but I'm quite knowledgeable about them. So maybe as a highly informed observer, I feel like we really should try to draw this distinction between actual intelligence and mimicking that intelligence, right? And I feel like we're at the point where we're getting to be pretty good at mimicking it, but I do think that crossing that point at which this becomes an actual artificial intelligence that is capable of independent thought and whatever else we may ascribe to the notion of intelligence, I don't think we're there yet. So in that sense, I'm maybe more of a skeptic, but I've been wrong a million times before, so who knows?
Yeah, and I have interviewed people on both sides of the camp. So your ex-colleague, probably Dr. Duncan Pritchard of UCI, was on the camp that these systems are not knowers. They are, mainly statistical machines. And I also interviewed other people who believe that, what is the brain? The brain is a statistical machine. When you are saying anything, you are prompting my brain to generate a response, and based on the data that I was trained on since I was born. So some people are on this side and some people are on the other side, and I'm here in the middle asking questions and trying to figure out what my personal beliefs are. But it's definitely a fascinating topic, and I love talking about it. And I think a lot of people should be considering talking about it. I had a guest who believed that even ChatGPT, on a scale of sentient, or on a scale of consciousness, is to a degree has a degree of consciousness, and does not think that it is in the realm of impossible to consider these systems as conscious at some point. Where do you do you put a lot of thought into this? I mean, I'm fine if you don't, but it's just curious to know your stand here.
I mean, in a way, you're one, not you personally, but all of us, we were forced to think about it because we're just bombarded with this. And the world that I live in has been, in a way, reduced to a single dimension, which is everything boils down to AI. Everybody wants to further advances in AI. Everybody wants to fund research in AI. Everybody wants to produce technology that relies on AI and so forth. So you can't really not think about it. Having said that, I am probably more on the side of your previous guest who or guests who have equated this to very large statistical machines. I do feel like our own intelligence, at least because of the fact that it lives in the analog world, is different. It's still different. It might not be forever different, but I tend to give us more credit than what I'm able to see from these machines. Having said that, we absolutely have to acknowledge that they are pretty darn close to what we might think of as intelligence. They're pretty close to being able to mimic it. Are we at the point of them independently being able to make decisions that, I don't know, could endanger us the way HAL did in 2001: A Space Odyssey, the famous movie? I don't think we're there. I'm not necessarily concerned about that. I'm, generally an optimist. I feel like we can, if we don't abuse this technology, we can hopefully use it to help us solve some of the real problems we're dealing with. But yeah, I'm still in the wait and see camp. I'm not convinced that this is I don't think it's what I would call an intelligence at the level of what we might consider among humans or even some other primates or even birds for that matter. I do feel like it's an incredibly interesting set of technologies and tools, but I'm also keeping an open mind. Obviously, I can be surprised going forward, I guess.
For sure. Now, in your field as software engineering, and you obviously have a lot of students and involved in the field, what impact do you see this technology has on software engineering or on software development in general?
Yeah, so that to me is a fascinating question. Partly because, as I already mentioned, everybody nowadays wants to jump onto these new technologies, work with them, use them in various ways. Since I live in a academic research environment, all the funding agencies, from the Department of Energy to ARPA-H to the National Institutes of Health to the National Science Foundation to DARPA, et cetera, all of them are really looking to harness the power of AI to solve whatever problems. And for them, for many of those problems, AI actually can bring an incredibly powerful set of tools and capabilities to improve what we've been able to do in the past or so far. But the one thing that I feel like is getting lost in this equation is the fact that it's not like we were just at the top of the hill, 2 years ago when ChatGPT came online, or I don't know, 10 years ago when neural networks finally started delivering on some of their promise, because both some of the models we've been able to develop and some of the machine learning advances that came about, and the power of the kind of the computational infrastructure all reached this sort of nexus where some of these things became possible. But it's not like at that point we were like, hey, we solved all the problems so that we've been dealing with so far. So how about if we move on, take this quantum leap in a sense and move on to the next generation of problems? That is actually the attitude that you see a lot today, where people are ignoring some of the old stuff in many ways, and just everybody's jumping on this new bandwagon. And I feel like that's actually a mistake. And I'll give you a very simple example of why that is, because it came up with a discussion with engineers from an actual real world company that both you and I have heard of. And I don't want to say which company it is because I don't want to implicate anybody, and I don't want to make it seem like somebody's struggling while everybody else has solved the problem, because I believe that, you could substitute Microsoft or Google or Snap or, whatever, Meta or any large company, Northrop Grumman, Boeing, whatever, that builds software. You can substitute for this, and I think the problem would be exactly the same. And the issue that came about had to do with the fact that tools like GitHub Copilot can be used to solve simple programming problems. And they, in fact, can be used because they rely on very large statistical models that learn from huge code bases, among other things. They can also be used to solve maybe more complex problems. And that's great. You can improve the productivity of an individual engineer by not forcing them to do things by hand. In other words, by allowing them to leverage these tools to automatically code up a solution to some problem that otherwise they might have had to do by hand. And that, again, as I said, that's fantastic, right? We're basically allowing engineers to focus on things that really matter and giving them the opportunity to steer away from spending their time on problems for which solutions are constructible in other ways, maybe automatable, right? The thing that came up in this discussion that I think we don't know how to deal with, and we'll never know how to deal with, this is not going to be an easy problem to solve for at least the next couple of decades, is my guess, if not further into the future. But even when we arrive at those solutions, there are going to be potential problems associated with it. So this goes back, if I can just back up for a second, to this nomenclature that Fred Brooks, who's a really famous computer scientist, came up with in the mid to late 1980s, where he discussed essential problems of software engineering versus accidental problems. And I think this falls in the realm of these essential problems for which we're really not going to have effective solutions, simply because those problems are always going to be there. We don't know how to solve them because they're inherent to this task of software development. So what is the issue here? The issue is that, let's say you and I are on the same team. I use, let's say, Copilot to code up a piece of, solution, an algorithm, solution to a problem. You use Copilot to code up a solution to a problem. Now we try to integrate our code, and then we combine that with some of the stuff that's homegrown that both of us implemented manually. And my code works okay; it passes some simple tests. Your code works okay on your end. Now we integrate it, and something doesn't work right. That is a very hard problem. That kind of integration problem is something that software engineers struggle with all the time. And it goes beyond just two developers, but this is a very simple scenario, right? It's just the two of us. And somebody has to sit down and figure out what that problem is. And if you wrote the code completely and I wrote my code completely, we sit down, we put our heads together, and eventually we can arrive at the source of the problem, where the integration breaks, right? What is the root cause behind the fact that your code works okay on its own, my code works okay on its own? When we put it together, there are these emergent properties, right? These things that either violate some security policy or make the code unreliable or just make it not work, period, right? The issue that comes up and has already come up, and I'm glad that people are beginning to talk about it because it seemed obvious to me from the get-go, is, well, it's incredibly hard to do this when some of the code we didn't write. Neither one of us did. How do you understand the code that came out of a tool, right? That's not yours. You have to go in there and figure out what's wrong with it, right? And that makes this problem of debugging, integrating and debugging code significantly more difficult. And this is where I feel people are finally beginning to experience some pain points, and they're going to start to pay attention. Because what you want to do is you want to apply these tools, what I call, the power screwdriver, right? You want to apply your power screwdriver because it's going to make you more productive. But you also want to be very keenly aware of the limitations or the potential pitfalls. You have to really watch out for it. And this is something that is finally beginning to be recognized after this initial kind of wave of excitement and hype has come about. And I hope that people are going to continue talking about it, because these are problems we didn't really know how to solve before, and they're only going to get exacerbated now. And this whole attitude of, we're just going to focus on AI, we're just going to work, everybody's going to work on AI. I think that's a very dangerous, from my perspective as a software engineering researcher, that's a very dangerous trend, because it ignores the fact that we had all kinds of problems with classical systems, traditional systems. Now we're making them that much more complex. So the level of problems we're going to experience is going to grow as well. At least that's my expectation. I'm pretty sure that's accurate. So ignoring those problems is not a good.
Yeah, and that's probably the next question I have for you is that, you know, I feel that it's the iPhone moment again, where a lot of big companies, I remember Nokia and BlackBerry and all of these technologies, they were, doing their best years in they're doing very good in the economy. And then suddenly a new technology, the touch phone, the iPhone came, and they kind of like, they couldn't compete anymore. They couldn't convert into that space. And a lot of these legacy softwares that, a lot of companies rely on, a lot of people use, they have a huge challenge right now to really like adopt these generative models and integrate them within their systems. And this could potentially throw a lot of companies out of business. Do you see that happening, or what would be your advice for a software company that is a legacy software? What do you tell them to do?
There is a philosophy that a more senior colleague of mine espoused in his research and shared with me at one point, and I thought it was very, I think, prescient in a way, and I've tried to use that in my own research, which is he said at one point, there are people who will just kind of go after the new shiny thing and try to sell their work as if it's solving whatever the problem du jour is, right? Whatever the flavor of the day is. My philosophy is, in my research, is run silent, run deep. And I think for many of these companies, if they're really solving an actual problem, if it's useful to their customers, if these systems have been around for a while and they have stood the test of time, I think they're going to be okay for some time in the future. The issue is going to be, as you already mentioned, how do you, for example, integrate these generative models in a way that's going to provide the next generation of capabilities to their customers? And I think it will be incredibly important to invest the time to do this right. I don't think we have really the first notion about what it means to build effective hybrid architectures. I've spent my research life studying software architectures for many, many years of traditional systems, and nowadays migrating to some of these more novel neural network based systems. And I feel like it's a large unexplored space. People have struggled with updating their systems, making sure they scaled, making sure they move through various technological trends, even in the original traditional model of software development. Now, with these new neural network based architectures that come on the scene, I feel like the problem is exploding in terms of complexity, and it's really, really important to do this right. So between doing it fast and doing it right, I would always advocate for doing it right. Now, I know that many people, if any, are not going to listen to this, and they're going to try to go fast because you got to pay the bills, you want to capture market share, etc. This is where the notion that we've dealt with in software engineering for several decades of technical debt, I think that's just going to balloon. It's going to explode. So in a way, I'm actually heartened by that proposition, because that means many years of potentially very fruitful research problems for people like me. But meanwhile, yeah, there are going to be companies, as you mentioned, that are likely to go under, companies that are not going to be able to deliver their products that are not going to operate the way or as promised. And so we're going to see some upheaval out there. It's going to be interesting how the next few years play out, because now everybody is in the process of just generating their own LLM, right? And putting it out there. So Microsoft has Copilot, and I don't know, Google has Gemini, and obviously OpenAI has ChatGPT, and Apple is now trying to incorporate that into Siri. So you see this kind of positioning, but eventually I think that's going to wane. And at that point, we're going to start paying attention to actual engineering problems behind delivering very large scale systems that may use these things as utilities. And that's where the interesting stuff is going to come up.
So your computer science department at USC graduate perhaps hundreds, if not thousands, of students every year. Do you see there is going to be any impact on employment and jobs for these software engineers that you teach and they are graduating year after year? Is there going to be enough jobs for them? What's the impact on jobs in general, in your opinion?
So there are two answers to that, and I'm glad that we're actually touching upon this before we ended the interview because I think it's an important issue. There are two answers to that. There's a short term answer and a longer term answer. There may be blips short term. There are going to be potentially companies out there that might have ordinarily hired a lot of people who will just go, hey, instead of 10 junior engineers, we'll just have one slightly more experienced engineer who can do some prompt engineering and ChatGPT, and that'll do the job of 10 junior engineers. I think that attitude may prevail for a while before people realize that you really need human engineers to solve some of these other problems. And I feel like from the world that I live in, being able to gather software requirements and understand them properly, being able to develop actual architectures that will properly deliver such qualities of service and satisfy such requirements, being able to integrate the work of multiple different engineers and help them communicate with one another and solve problems that go beyond just coding up simple functions or algorithms. Things of that sort are going to require well-trained engineers for the foreseeable future. So I feel like if there is a correction in the short term where companies might not hire as many people, I think that's going to eventually kind of recorrect to the other side, where I feel like we will be able to maintain the current effective 100% employment rates for our graduates going forward. So that's kind of more of a mid to long term prediction. I do acknowledge that in the short term, there may be blips where people might find that jobs are not going to be as easy to find as they might have been like 5 years ago, in the sense that instead of getting 10 different offers, you might get two, right? That kind of thing. I do think that that is not beyond the realm of possible, but any expectation that these tools are just going to be able to replace engineers, I think, are silly in my mind.
When it comes to majors, though, are there majors that are more resilient to the automation powers of AI? Like, if you're someone who is in high school and in the process of choosing a major, do you think there are some majors that are more resilient against this wave of automation that AI brings?
That's a different, in a sense, a different question because it's broader. I could maybe speak with greatest authority about the two classes of majors that we control, in a sense, that we run within the CS department at USC, which is computer science in the various flavors and data science. And I feel like certainly data science types of jobs are going to be there for the foreseeable future. Computer science jobs, I don't see being impacted in a significant way by AI. Certain types of CS jobs may be, but then they're going to, as has happened in the past, other things will open up. And we're actively actually looking right now at what impact all of this is going to have or should have on our curriculum. In other words, how do we adjust so that we're agile enough and we can make sure that our graduates are both foundationally trained the way they should be within the field, but also employable. So maybe you and I could, schedule another one of these in a year's time and revisit. Simply because we're kind of in the eye of the storm right now, right? So it's very hard to see the big picture. I can tell you what some of my views are. I feel that we're not going to be able to replace humans, and the absolute need for them to communicate and to share information and to discuss that information, to understand that information, because any and all of this ultimately is done in the service of humanity. So every time you build any kind of utility, it has to solve a problem that somebody has, right? And very often this happens in software engineering all the time. And it certainly happens in software engineering research where, we laugh with one another about very often having a hammer and looking for a nail, right? So I have a technique that works really well and now have to find a problem that technique can be like an actual problem it can be applied to. And I feel in some ways we're treating AI in the broad sense a little bit like that. It's a very powerful tool. Let's see what all the different problems are that it can potentially be applied to. But ultimately, it has to solve problems that are of use to humanity, and there are going to be so many of them out there for which actual humans are going to be required to sit down and think through them. That I am quite optimistic will be okay. But as I said, maybe we should revisit this in 12 to 18 months.
So the follow-up question on this one is that, because AI is such a transformative technology and there's it will create different fields that are in general multidisciplinary, like for example, AI safety combines ethics with other areas. Do you think we're going to see more demand on areas like philosophy and linguistics and other domains that are before this technology were not that popular among they were struggling to find jobs besides academia? Do you think right now with this technology we will see more opportunities for areas of humanities that we previously considered or previously thought that they are not much useful from the economy standpoint?
That's actually a very good question. And I think that certainly one of the areas that has become of great interest generally, but also specifically within USC, is ethics and professional ethics, but also ethics as applied to building these systems, understanding them, ensuring that they perform the way they're supposed to perform, that they don't discriminate, and so forth. These are very complex issues, and I think that in many ways, whether we start studying them with kind of the way maybe we approach a lot of problems in this area, which is sort of from first principles, or more likely and possibly more productively incorporate the knowledge from other areas like philosophy, as you mentioned, with its own treatment of ethics, possibly psychology. There could be, sociology and other potential areas of humanities and social sciences. I think that's yet to be seen, but there is definitely going to be a push in this direction. And I can already tell you that just looking at our curriculum and how we want to approach training our own students at USC, we're definitely already beginning to move in that direction.
My last question to you, and as I look at your background, you have a beautiful art behind you, and the question here is that would we see you one day putting an AI generated art in your office or in your living space, or would you stick with the human brush?
That's a very interesting question. I hadn't thought of it. Just as you were talking about this right now, or asking the question, my first thought was, why not, right? I don't have any problem with using AI generated art. The interesting ethical dimension to it, of course, is at some point, will AI generated art start replacing human generated art? In other words, will it start impinging on the ability of human artists to make a living, right? I think I would like to hope that there is going to be a place in the world for both. I don't object to, beautiful, interesting imagery that, asks questions and inspires the mind and so forth, regardless of where it came from. But just in the middle of your question, I do have to acknowledge that I actually thought of, since you asked a few minutes ago about AI replacing engineers, what about AI replacing artists, right? And that's a potential ethical dilemma that I would have to think through. So it's a qualified yes, but we'll see.
Dr. Nenad Medvidović, thank you so much for your time.
Thank you for having me. It was fun.